Hello friends, I welcome you on my channel Engineering Mathematics djganit. In last two lectures we have discussed the examples in which we discuss how to show that given limit does not exist, and for that it is enough to find out two different paths along which limit is different. Now today we are going to discuss how to show that limit exists and how to prove that this is the value of given limit. So for this we first understand the definition of limit of a function of two variables. It is similar to the definition of function of one variables. So what is the definition? Before understanding definition, we just recall that if we have 2 points in xy plane, suppose I have 2 points, say order pair AB and order pair xy in xy plane, then the distance between xy and AB is denoted by absolute value of xy minus AB. This is the distance between these 2 points, and the formula to find out distance between these 2 points is square root of difference of x components, that is square of x minus a plus square of y minus b. So we will require this formula to understand the definition of limit. Now when we say that fxy, limit of fxy as xy tends to fixed point AB is L. So we try to understand the meaning of this mathematical statement. This says that when xy is approaching the points xy, whenever the points xy in the xy plane are approaching this fixed point AB from any direction, then this fxy is approaching a fixed real number L. So this xy is approaching AB in xy plane, and this fxy is approaching this real number L on the real line. So here if we consider fxy approaching L, then we are talking on the real line. So here the distance between fxy and L is nothing but absolute value of fxy minus L, where fxy and L both are real numbers. And in this case the distance between xy and AB, so this is the distance in xy plane and this is the distance in on the real line. So the simple meaning of this statement is when fxy is going very near to L, that means on the real line. So when fxy is going very near to L, so as xy is approaching AB, if limit exists and limit is L, then when xy is approaching AB, then fxy is approaching this fixed real number L. This means whenever the distance between xy and AB is going near to 0, okay, from this we can understand that when xy is going very near to AB, distance between xy and AB is being very small, so it is going very near to 0. So whenever this distance is going near to 0, distance between fxy and L is also going near to 0. So informally we can say that if we want to prove that limit of fxy is L as xy is approaching AB, we can say that, or we have to show that whenever this distance is going near to 0, this distance is also going near to 0. So this distance depends on the distance between xy and AB. Whenever distance between xy and AB is being arbitrarily small, this distance is also being sufficiently small. So the distance between fxy and L depends on the distance between xy and AB. Whenever there is a change in the values of xy, there will be a change in the function. So fxy depends on the behavior of these points xy. So whenever xy are approaching the fixed point AB, fxy is approaching L. If we can show this, then we are able to prove that the limit is capital L. So for that, the idea is, suppose distance between fxy and L is less than some positive real numbers denoted by epsilon. Epsilon greater than 0 is any positive real number. So suppose we want to make this distance smaller than epsilon, then we have to find that the distance between xy and AB is smaller than which number. So suppose we want to make the distance between fxy and L smaller than some positive real number epsilon, then for that the distance between xy and AB should be less than which number. That number is denoted by delta, such that if distance between xy and AB is less than delta, that implies that fxy and L is less than this positive number epsilon. So if this is true for every epsilon positive, that is, if for every epsilon positive, if distance between xy and AB is less than delta, implies distance between fxy and L is less than epsilon, then we can say that limit of fxy is capital L as xy is approaching AB. So for every epsilon positive, we have to find out a number delta greater than 0, such that whenever distance between xy and AB is smaller than delta, the distance between fxy and L is smaller than epsilon. So this is the way how we can define limit of a function. So we just read the formal definition. Limit of a function. So you can see, let f be a function of two variables whose domain capital D includes points arbitrarily close to this fixed point AB. So we want to determine the limit of this function f as xy is approaching this fixed point AB. So this is the point at which we want to determine the limit of a function. So we have the domain of function must include points which are very near to which are arbitrarily near to this point AB. Then we say that the limit of fxy as xy approaches AB is capital L, and this is the notation. Limit of fxy is capital L as xy approaching AB if for every number epsilon positive there is a corresponding number delta positive, such that if xy is in domain capital D of a function, and if distance between xy and AB is less than delta, then distance between fxy and L is less than epsilon. So if distance between xy and AB, which is square root of x minus a square plus y minus b square, is less than delta, then distance between fxy and L must be less than epsilon. So if for every epsilon positive there exists delta positive, such that if this distance is less than delta implies this distance is less than epsilon, then we can say that limit of fxy is capital L as xy is approaching AB. So whenever we have the idea that limit exists, then we have to prove by definition of limit of a function. So for that we will try to find out this type of things. While proving that limit exists, we can try to find out this type of things. So as we discussed, distance between fxy and L depends on the distance between xy and AB. Suppose we want to decide the limit at point AB, then this distance depends on this distance, because f is function of x and y. So behavior of this function f depends on the behavior of this point xy in the domain of given function f. So this distance between fxy and L depends on this distance. So while proving that limit exists, what we will try to show, we will try to prove this type of inequalities. This distance is less than or equal to some constant times this distance. So if we are able to show this type of things for some alpha, then from this we can have the idea that suppose we are able to prove this inequality, distance between fxy and L is less than or equal to alpha times distance between xy and AB. So suppose we are able to prove this inequality, then if this distance is less than epsilon, then you can see fxy minus L, distance between fxy and L will be less than epsilon, because this distance, this value is bigger than this value, and this bigger value is smaller than epsilon. So if this is smaller than epsilon, then because this is smaller than this value, fxy minus L has absolute value less than epsilon. So if distance between xy and AB is less than epsilon over alpha, if this distance is less than epsilon over alpha, then distance between fxy and L is less than epsilon. So this will be our corresponding number delta. We will call this as delta. Here we should write alpha non-zero. So for examples, we will try to show that distance between fxy and L is less than or equal to alpha times distance between xy and AB. And if we are able to prove this inequality, our delta will be epsilon divided by this constant alpha, which is non-zero. So let us try to understand how to prove the limit. So here function is 3x square y over x square plus y square. So first we denote it by fxy. Let fxy is 3x square y over x square plus y square. The fixed point is origin. We want to decide the limit at origin. Suppose this is x-axis, this is y-axis. Now here function is 3x square y over x square plus y square, and we don't know whether limit exists or not. So first we have to decide the existence or non-existence of limit by taking different paths, as we have done in last two lectures. So as usual, we first check along the lines passing through origin. So if we put y equal to mx in this function, then we can see it is 3x square, y is mx, x square plus m square x square. So if we simplify this, x square will cancel out, and we are left with 3mx divided by 1 plus m square. And when xy tends to 0, 0, and if we put y equal to mx, we will have x tending to 0. So if we take x tending to 0, this is going near to 0. So that means along every line passing through origin y equal to mx, limit of this function is 0. So we are getting this same limit along all the lines passing through origin. So let us try for limit along parabolas. So now we try to find out value of function along parabolas. So we put y equal to mx square. So function is 3x square y. So 3x square m into x square over x square plus y square. So x square and y is mx square. So we have to take square of y. So it is m square x raised to 4. Again we can cancel out x square by taking common. So we will be left with 3mx square. 1x square will cancel out and there will remain 1 x square. Here also 1 plus m square x square. So you can see if we take limit as x tends to 0, we will have 3m0 over 1 plus 0, and here m is different from 0, so this is going to be 0. So that shows that limit along all the parabolas passing through origin is also 0. So in this problem, if you try along different paths passing through origin, you will see that we are getting this same limit along different possible paths. We have checked for y equal to mx and y equal to mx square. You can check for y equal to mx cube or x equal to my square or y equal to mx raised to 4. So you will see that all the limits are having 0. Well, limits along these different paths is 0. So from that we cannot say that limit is 0. There are infinite number of paths possible from origin. So if by putting 4 to 5 different families passing through origin, we cannot say that limit exists. Okay, so what we can try to do is we can try for different paths. Y equal to mx, y equal to mx square, x equal to my square, y equal to mx cube. So by putting these different paths, we will have the idea that limit exists or not. So if you try these different paths, you will see that in limit is 0 along all the possible paths. So here we will try to show that limit is 0, and that we will try to prove by definition of limit. So here first we write that to prove that limit of fxy as xy tends to 0, 0 is 0, and we denote it by capital L. Say it is capital L. Now here fixed point is origin. So as we know, distance between xy and origin is nothing but square root of x minus 0 square plus y minus 0 square, which is square root of x square plus y square. So and limit capital L is 0. So first we will try to prove this type of inequality between these two distances. We will try to show that fxy minus L, distance between fxy minus L is less than this distance between xy and 0, which is under root of x square plus y square. So if we are able to prove this part, then we are done. So we just start from this distance, and by trial and error we try to see whether we are able to prove this type of inequality or not. So we just try from fxy minus L. So now distance between fxy and L, which is absolute value of fxy minus L, this is equal to function is 3x square y over x square plus y square. Capital L is 0. So this is nothing but absolute value of 3x square y over x square plus y square. Now absolute value of 3x square y over x square plus y square is absolute value of 3x square y over absolute value of x square plus y square. So therefore I write here absolute value of fxy minus L. This is nothing but, now 3x square is non-negative, so absolute value of 3x square is 3x square over x square plus y square, because x square plus y square is also non-negative. And one more thing, here xy is approaching 0, 0, but it will never be equal to 0. That means x is non-zero and y is also non-zero. So x square plus y square is non-zero. So there is no problem if we divide by x square plus y square. So this is the simplification of distance between fxy and L. Now if we observe one thing, we know that x square is always less than or equal to x square plus y square for all values of x and y. So from this we can say x square over x square plus y square is less than or equal to 1 for all values of x and y. So that means we can use that part here. If we consider this part, x square over x square plus y square, this is less than or equal to 1. So that means this is less than or equal to 3 times absolute value of y, using this fact. Now absolute value of y can be written as square root of y square. So therefore we are able to write fxy minus L has absolute value which is less than or equal to 3 into square root of y square. Now again we use this fact, y square is always less than or equal to x square plus y square for all xy. So that means square root of y square is less than or equal to square root of x square plus y square for any xy. So this I can rewrite as this is less than or equal to 3 times square root of x square plus y square. So finally what we obtained is, therefore distance between fxy and L is less than or equal to 3 times square root of x square plus y square, or we can say that distance between fxy and L is less than or equal to distance between xy and origin. So we give this number 1. So you can see we are able to prove this inequality, and here we obtain alpha equal to 3. So now we consider, suppose epsilon is any positive real number, let epsilon greater than 0 be given. So from 1 we can say that distance between fxy and L is less than epsilon if this is less than epsilon 3 times distance between xy and 0 0 is less than epsilon. This is true if distance between xy and 0 0 is less than epsilon by 3. Now epsilon is positive real number, so suppose we denote epsilon by 3, which is also a positive real number, by delta. So if this distance between xy and 0 0 is less than delta, then this distance is less than epsilon. So this is true for all xy. So we have shown that for given epsilon positive, there exists delta equal to epsilon by 3 positive, such that whenever distance between xy and 0 0 is less than delta, distance between fxy and L is less than epsilon. So therefore we can write for given epsilon positive, there exists a delta equal to epsilon by 3 positive, such that if distance between xy and 0 0 is less than delta, then distance between fxy and L is 0 here, is less than epsilon. So therefore limit of given function as xy tends to or xy approaches 0 0 is 0. So in this way we can prove that limit exists, and we can have the idea about the value of limit by taking different paths. So whenever we consider any example of limit of functions of two variables, first we will check by taking different paths. So if we are getting same limit along some 4 or 5 paths, then we can have the idea about the value of the limit. Here we have first put y equal to mx, then mx square, and you can try for these different paths, and from that you can have the idea that we are getting the same limit. So from that we will have the idea that this might be the value of limit. Here we have seen that we are getting limit as 0. We obtain that limit along y equal to mx is 0, limit along y equal to mx square is 0. So from that we got the idea that the value of this limit may be 0. So from that we find out the value of capital L. Then we try to prove that 0 is actually the limit of this function. So for that we are using definition, and you just have to remember this inequality. Try to prove this inequality, that distance between fxy and L is less than or equal to alpha times distance between xy and AB. So if limit exists, then you will always be able to find out value of alpha, and your delta will be epsilon over alpha. And if limit does not exist, then you will have some difficulty in proving this part. So you can try for finding out different paths along which limit is different. So this is all about today's lecture. In the next lecture we will discuss some more examples on how to show that limit exists by the definition of limit. So I hope you like this lecture. If you are watching this lecture first time, then subscribe this channel for learning this whole lecture series on calculus. Thank you very much.